Okay, so today's lesson 3, is on slope. So please quiet down, finish your texts, whatever, put your phones down, disconnect, and focus on me, please. You have rate of change as the title, and this essentially means slope. So this is essentially slope. And remember we talked about rates yesterday. What's a rate? What's a rate? Ratio between what? Good. Two different quantities or units. Good. And the most common one, if you're like driving in your car, kilometers per hour. We did some quizzes, you know, it's like dollars per kilogram, like if you're buying potatoes or something. Okay? So you've seen it. It's not too challenging, but there is some unit conversions that might get you messed up a bit. So your unit conversions have to be good, and just understand what a rate is. And we'll use graphs. And if you take a look at this graph, what's it graphing? Temperature versus time. Go on. Welcome back. All right. So you'll just have to hang out, you guys. No worries. Just hang out today. Yep. All right, so if you take a look at the first graph, oh, you are around? All right, let's try that again. Let's see if we can do this. Okay, so Robin here is making taquitos. That's an interesting choice. Okay. And she is going to preheat the oven to 400 degrees Fahrenheit. So I guess if you take a look at this graph, what are they graphing? This looks like temperature versus time. So just jot that in, and you'll start to appreciate that it's always going to be like this, y versus x. So you have the y that goes vertically, that vertical scale, and you have this horizontal scale, x, for time. And it's degrees Fahrenheit, so the American temperature, and then minutes. So let's go take a look at this investigation. So what does the point 050 on the graph represent? Taking a look at part A. Yeah, so read it, the first coordinate first. 0 is time, and 50 is temperature. Good. So what does it mean to have a 0 time? You haven't started yet? Good. So we call that the initial value. And then in math on that graph, you can see it's represented by the y-intercept. It's the y-intercept because the x component is 0. The x component is 0. So that might be like room temperature. It's Fahrenheit, yeah. So I think 32 Fahrenheit is like freezing. So it's probably room temperature. Okay. What does the point 5, 400 on the graph represent? Good. In 5 minutes, good. It's good, 400 degrees Fahrenheit. Beautiful. So that's the time it takes to preheat the oven. Yeah? Okay. And this relationship up here, this is linear. And linear relationships follow the formula y equals mx plus b, where m is the slope and b is the y-intercept. Good. And then, of course, y and x are always needed in the formula. Y is the dependent variable. Notice it's alone on the left. X is the independent variable. So you have to change x, and then you'll get some corresponding y. So it totally just depends on the time, and then you'll get the corresponding temperature. Okay, let's go ahead and calculate the slope of the line. Okay. Slope of the line. They gave me a lot of room to do this, so let's just do it off to the side. Slope is y2 take away y1 over x2 take away x1. This is the formula for slope. All it's saying is that what's the change in y? What's the change in x? And then just divide them. It's the second point, take away the first point, and you just do it coordinate by coordinate. So where is y2? Good, 400. That's y2. And where's y1? 50. Excellent. So what's the change? 350. Very nice. Okay. So 400 take away 50, that would be 350. Now how about the x? Where's x2? 5 and x1 0. Good. So 5 take away 0, 5. And we can finish this off. 350 divided by 5 is 70. Good. Now, because this is a rate, you need to be aware of units. And you notice I was lazy. I did not take care of units. I know. So what are the y coordinates? What units are the y coordinates? Degrees Fahrenheit. And what's the units for x? Time in minutes. So this rate of change, this 70, is actually 70 degrees Fahrenheit per minute. This is what we're looking for. What that means is as every minute progresses, 1 minute goes by, 1 minute goes by, 1 minute goes by. You go up 70. So what's the temperature at 2 minutes? 140. Good. What's the temperature at 3 minutes? 210. Good. Feel that? Good. It's like a step ladder. Okay? It's like a step ladder. Over 1, up 70. Over 1, up 70, and so on. You guys okay with that? That's staircase model. That's rise and run. That's straight lines. Okay, so the book wants us to be careful about our vocabulary. So rate of change, slope is this. I got it highlighted there for you. And that would go here. 70 degrees Fahrenheit per minute. Let's fill that in. 70 degrees Fahrenheit per minute. Okay, this is an example of positive slope. The next example, part 2, is an example of negative slope. I love this example. Imagine you just had like a big barrel of water. It's filled with water. You jam a hole in the bottom, and the water starts flowing out of the bottom. What's happening to the water level? It's lowering, it's decreasing. So you can model the water depth or height or whatever it is versus time, and it will be decreasing. It's a good example. So water is leaking out of a bottom of a barrel at a constant rate. That implies that it will be linear. If it says constant rate, that implies linear. So after 2 minutes, the water level is 62 centimeters. So what we need on the grid is to plot these ordered pairs. That's what we're going to do in part A, where x is time and y is water level. So you can put that here. On x, you can put time. And it looks like it's in minutes. And for y, I'm just going to put height, okay? And that's in centimeters. Good. So what's that first ordered pair that they gave you. After 2 minutes, 62 centimeters. And after, oh, that was in a bad spot. Put it up here because it's decreasing. At 2, it's 62. And 5 minutes later, it's at 722. You can use your straight edge tool. You guys all have those, right? Straight edge tool. You don't have ID card? Unless you gave it to me for your calculator, you should have an ID card or a bank card. Credit card, maybe. Some of you came prepared with a ruler. All right. So let's calculate the rate of change here. First of all, just jot down the formula. Remember M, and I'll write this all really longhand on this one, but you don't have to do this. Delta Y, delta X, Y2 minus Y1, X2 minus X1. And just keep in mind that this is the rise divided by the run. These are all the same thing. Okay, let's plug in. Where could I find Y2? And how do I always say the second point is to the right? Good. So where's Y2? Good. And where's Y1? Good. So Y2 and Y1 you can sub in now and you get 22 minus 62. And we got X2 at X1. So 7 take away 2. So 22 take away 62, what is that? Negative 40. And you're going to divide negative 40 by 5. Okay. So what do you get there? Negative 8. And now we need the units. Remember, the units for Y go first, and then the units for X go next. So centimeters per minute. So what does that mean? Every minute you lose 8 centimeters. So the water level is changing at the rate of negative 8 centimeters per minute. Or in other words, it's decreasing by 8 centimeters per minute. So they're just using a vocabulary there. It's changing by negative 8, or in other words, it's decreasing by 8. So are you going to have to know how to calculate slope for your first test? Yes. And are you going to be able to be lazy with your units? No. Okay. And are you going to see rate of change on your test? Yes. So make sure you're studying this rate of change. And you can see we only have one more example. So this is going to be nice. If you look at your book, if you flip through your book, you will always see this little guy, this little stop note guy. That's essentially where the book is going to show you a whole bunch of summarizing notes. So if you're studying, look for those stop notes. Okay, it's a good little tip. And you can see here, boom, that's pretty important. That's something I would put on a study sheet. I don't really do study sheets, no. I'm not that nice. There's no study sheet on the diploma, so kind of is what it is. Maybe I'll give you guys a study sheet for quadratics, because that one's tough. The quadratics and the radicals, yeah, I might give you guys some study sheets, depending on how good you guys are. Those are the two hardest, quadratics and radicals. So if you're looking for study sheets, it'll be then. Okay, we got Dave here. Dave's going to enter his car into a long distance race. He travels the first 150K in 2 hours, and after 6 hours, he had traveled 650K. So first of all, remember, y depends on x. So which one is which? Does time depend on distance, or does distance depend on time? Like 99% of the time, x is always time. You'll see in 30-2, we do this thing called the logarithm, and that's the one example where time might be on the vertical. But like I said, 99% of the time, x is time. So then the y must be the distance. Okay, so you have distance versus time, and remember that distance always, or the y goes vertically, and the x goes horizontally. So for the y, you're going to put distance, I'll just put d, and for the x, we're going to put time, t. Distance versus time. Now they want you to plot the ordered pair and represent this information and explain why 0, 0 is included as an ordered pair. Got to start somewhere. I like that answer. It is a good answer. It's common sense. So don't be afraid to use common sense. Let's put in 0, 0. That's not too bad. At 0 time, you haven't gone anywhere. What would we call that? An initial value. And that is also called the y-intercept. Good. Good. So what's that first 2 hours? And he goes 150? Beautiful. Let's put a scale on here. Do you see how there's some thick lines? 1, 2, 3, 4, 5, and 6. Okay. So the thin lines would be half of those. Now for distance, how far do we go? We got to get to 650. How many scales do we got? Lots, hey? Okay, let's just go by, let's go by ones. 100. You guys want to skip? Yeah, let's skip. So let's go 50, 100, 150, 200, 250, 300, 350, 400, 455, 556, and then right up there where I got my y, that'll be 650. You guys feel okay about this? Okay, so let's plot the ordered pairs. The first one, this would be 2, 150. Where's that going to be? You go horizontally, find 2, and then you got to go up to 150. So right here, plot that point. Where's the other one? 6, 650. Okay, so got to find 6 way over here. Then you got to go up to 650 way at the top. Take out your favorite straight edge tool. And you connect. Oh, that was fun. Straight edge tool. And connect. What's interesting is that it didn't go through 0, 0. Oh, wow. Like, I teach physics and they say like you don't have to force 0, 0. So I'm not sure what they're trying to do there. Unless I screwed up. 150 goes with 2. And 6 goes with 650. Did I screw? I think I did okay. Maybe it's just my straight edge tool. Okay, so let's ignore the initial value. Good job, Absolute Value Productions. Unless I screwed up, but who knows. Okay, calculate Dave's average speed. So yeah, like in the physics class, I would not force that 0, 0. So you just want to calculate the average speed by the line of best fit. In this case, you have 2 points and 2 points only. So we're going to calculate average speed. You might remember this formula from a Science 10 or a physics. D over T. That is the formula for average speed. And in this case, we're going to use delta D over delta T, which is the change in distance. So how much did the distance change? You went from 150 all the way to 650. So we can find that change. And you started at 2 hours and you finished at 6. So you can find that change as this. And remember, distance is in kilometers and time is in hours. So you get that familiar speed unit of kilometers per hour. What's 650 take away 150? 500. Thank you. And 500 divided by 4 is 125. So this is like highway speed. 125 km per hour. So now I'm looking at C and wishing I didn't change my initial value. By looking at the grid and without doing any calculations, how can we tell that the average speed during the first 2 hours was less than the average speed during the next 4 hours? And I believe there was a young man named Trevette over there talking about the speed change. Do you remember that? So we were correct, and this book was okay. It was my mistake. If you draw this, and hopefully you're using a pencil, that was for that time frame. And remember, we started at 0, 0. We started at 0, 0. So we have this one here. So that initial value was okay. There was a speed change. And just by looking at the graph, how can you tell there's a speed change? The slope is different. It is linear in chunks. Do you agree? Yeah. And then what's the only thing you can say about slope? What is slope? Like, how could you define me? You're like, oh, he's a tall man, he's got dark hair, you know, he's handsome. How could you talk about this line? Like, what's this line's defining feature? It's steepness, right? That's all you can talk about. So which one is steeper? Yeah, this one's steeper. So just by measuring steepness, this one's steeper, and therefore the rate of change is greater, and in this case, it's faster. So hopefully you didn't make too many pen marks. Please use a pencil, because the way I do the math is that I explore it, I play with it, and if you have to erase, that's the way it goes. So for exercise, why don't you guys calculate the slope of the first line? We know the first one is, or the second one is 125 k per hour. That's for this one. Can you guys go ahead and calculate the slope for that one? Okay, so I know some people like formulas and they want to make sure they're doing everything right, but sometimes it's worth it just to think about this. Take a look. In 2 hours, you traveled 150. What's 150 divided by 2? 75. So that one is 75 k per hour. So 75 k per hour is obviously slower than 125 k per hour. So the rate of change is less. Okay, now let's talk about fuel consumption for Dave's Civic. Okay, the graph shown represents the amount of fuel in Dave's gas tank. So obviously, what happens if you drive a lot, your gas amount goes down. So the level of the gas, or the gas amount, the volume, whatever you want to call it, is going to decrease as what goes on? Time. Good. So as time goes on, the value drops. So you'll have a what type of slope? Good, a negative slope. Okay, for exercise, calculate this slope on your own. Right here, using those 2 points. So there's a couple ways you can look at these, especially if you're given a diagram like this on your test. You can just simply draw this right-angled triangle. Okay, so how much is that overness? It went from 20 to 120. How much is that overness? 100. And then you went from 50 to 40. So you dropped by 10. So it looks like the people that said 0.1, good on you. Rise over run. This is negative 0.1. And what's that unit? Liters per kilometer. So you lose about 100 milliliters per kilometer. Right? Sometimes metric messes us up, but that would be 100 milliliters, a tenth of a liter. Okay, so like less than a can of pop per kilometer. You guys feel okay about that? So if you're one of those people that likes formulas, I would do 40 take away 50 all over 120 take away 20. Get the same thing. Okay? Yeah, so that's the only place you could make a mistake, right? Getting them in the wrong spots or putting y in the bottom by accident. Did you do that? Did you do that? Yeah. Good. So be aware of the common mistakes and try to avoid them. Okay, so the amount of fuel is decreasing. Negative 0.1 liters per kilometer, or it's decreasing at a rate of 0.1 liters per kilometer. Okay, so the homework follows, and then you guys are out of here when? 2:48. So do homework for about 10 minutes, and then I'll send you the quiz.